What's up guys, Patrick here, welcome back. And in this example, what we got to do is find this limit here. Limit as x approaches 0 of the square root of 4 minus 2x squared minus the square root of 4 plus 2x squared all over 3x squared. So first off, notice we can't do a direct substitution in this case. We can't plug in an x value of 0 because the denominator would be 0. Notice the numerator would be 0 as well because this would be 0, this would be 0, so we'd end up having the square root of 4, which is 2, minus the square root of 4, which is 2. 2 minus 2 is 0. So we got to use some kind of other strategy. And there's actually two ways to do this limit. However, one way is a lot easier, in my opinion, than the other way. And I actually went through a similar example like this in the lecture videos, where you can find this limit here either doing rationalization or you can do L'Hopital's rule. But the problem with L'Hopital's rule, first off, the derivative of that numerator, it's going to start getting ugly with these two square roots, and we're going to have to apply the chain rule to both of these expressions. And not only that, because we have a 3x squared here, we're going to have to apply L'Hopital's rule twice. So we're going to have to find the derivative of this and this, which is going to be a little bit of work, but then we're going to have to find the derivative of both of those expressions again. Because the derivative of 3x squared is going to be 6x, and we're still not going to be able to make a direct substitution there. The denominator is still going to be 0, so then we're going to have to derive 6x, which is going to give us 6. So we're going to have to use L'Hopital's rule twice on this. So you can go about it that way if you want. You should get the same answer. It's just going to be a lot more messy. My advice for this specific limit is that you use rationalization. So what we would do is rationalize that numerator. So we would multiply by the conjugate. So basically these two terms are staying the same. We're just changing that sign in the middle. And this is going to be all over that same expression. So it's like we're taking this expression here and just multiplying it by 1. So what happens now is, because we're taking this, multiplying it by its conjugate, we just have to multiply the n terms by each other. It's going to be a difference of squares, so those middle terms are going to cancel out, so we don't have to worry about foiling it out. We just have to multiply this by that, which would just be 4 minus 2x squared. And then we got to multiply this by that, which would be 4 plus 2x squared, like that. And then these two terms I'm going to keep separate. So I'm going to have 3x squared here, and then I'll have the square root of 4 minus 2x squared plus the square root of 4 plus 2x squared, like that. And so from here, what we do is we simplify the numerator. So notice when we distribute this negative inside the bracket, we'll have 4 minus 4, so those cancel out, they net out to 0. Then we'll have negative 2x squared minus 2x squared. So we'll have negative 4x squared at the top over 3x squared times this entire expression again. Like that. And now notice the x squareds cancel out. And now we can do a direct substitution of 0 for x, because that denominator is not going to be 0 anymore. So if we sub in 0 for x here, we would have what? Negative 4 at the top. We got 3 over here. Subbing in 0 here, we got the square root of 4 plus the square root of 4, 2 plus 2, so that's going to be 4. So notice these 4's cancel out. Negative 1 over 3 is your final answer. Right, so quick recap. Two different ways to do this limit. You can use L'Hopital's rule. You're going to have to do it twice. It's going to get ugly. You can actually try it for practice. You should get the same answer, negative 1 over 3. But I recommend doing it with rationalization like this. Either way, final answer, negative 1 over 3.